Okay, let's finish up notes 20. First thing on number 10, we're going to, again, order of operations always applies to every single problem. We're going to clean up the inside before we raise to the exponent, because parentheses cleanup is first before exponents. So start with the 10 over 5. I can reduce that each by a factor of 5. It's going to leave behind a 2 and a 1. So already on the inside I have 2 over 1. Now let's clean up the x's. I have 5 x's on the top, an x to the negative 1 on the bottom. If I'm not comfortable with it, you know what, I made that parentheses too small. Let me make it a little bit bigger. Okay. If I don't like that the x's are negative exponents or any of them, I can go ahead and say, you know what, I'm not going to do the x's yet. I'm going to go ahead and bring that x to the negative 1 to the top. It's going to make it a y to the positive 1. An x to the positive 1. And I still have a y up there and a y to the 6th on the bottom. Let's go ahead and clean it up now. I don't like the negative exponent. It was just kind of making it messy. So one more step. We've still got the 2 over 1. Now I can clean up the x's. X to the 5th times x to the 1 is going to give me x to the 6th. That's a light-based problem, so you add the exponents. A y on the top and 6 y's on the bottom reduced by a y of 1, and now I've got 5 y's left on the bottom. Now I can raise everything to the 2nd power and it will be finished. 2 to the 2nd power is 4. X to the 6th raised to the 2 power. Power problem, multiply the exponents. That's x to the 12. 1 to the 2 power is 1, and y to the 5th raised to the 2nd power is y to the 10. Now I don't have to have the 1 there, but it's not hurting anything, so I'm going to leave it. Again, if you feel like I'm going fast at any point, you're surely welcome to stop the video and start the problem and then continue from there. Now on these, we're actually multiplying the tops and bottoms together. And another really cool thing that can happen is you can actually cross cancel, but I'm going to go ahead and do what's indicated here. We're going to multiply. When you're multiplying fractions, though, do you remember you could reduce within a fraction or diagonally? So that's the other thing that they want to show us here, but you can do it either way. Only on this first one will I do it both ways. If I go ahead and multiply straight across, I'm going to end up with 3x squared over y to the 3rd. And in the bottom, a 6xy. That I can actually reduce. 3 over 6 reduces to 1/2. Now the x's reduce and leave 1 x on the top. The y's reduce and leave 2 y's in the top. That's the answer. But the other thing that they wanted to show you, and that's probably the method I'm going to use, but I wanted to show you something else. When we multiplied numerical fractions, we said you should always reduce fractions within the term and diagonally before you multiply. You can do that here this way. The 3 and the 6 are in a diagonal, so they can reduce by a factor of 3 to 1 and 2. This x can cancel with one of the x's up here, and it's going to leave 1 x behind. Y can cancel with one of those y's, and it's going to leave 2 y's behind. So what you're left with in the top is 1xy squared over 2. Now, if you didn't like what I just did, please ignore it. It's the only time I'm going to show you how to solve a problem twice, but I am going to use method number 1, which is the highlighted one, for the rest of the problems. Okay, so let's continue. On number 12, and again, all I'm going to do is multiply straight across and then clean up from now on. When I multiply straight across, I'm going to end up with a 9. Oops. I'm going to end up with a 9, an x to the 3rd, and a y to the 3rd. By the way, when you have x's and y's, or any letters, multiple letters in a term, try to alphabetize them. It makes it a lot easier to work with. Now, the 6 would go first. The x to the 3rd would go second, and y to the 5th. Now we can start reducing. The 9 over 6 reduces by a factor of 3, and I get 3 halves. The x's completely cancel, And if I reduce the y's, I've got 3 y's on the top, I've got 5 y's on the bottom. It's going to leave me 2 on the bottom. Let's continue our last 2 examples. These are division problems. Since they're fractions that are being divided, remember our rule, we don't actually divide fractions. Instead, we multiply the first fraction by the reciprocal of the second fraction. So that just means flip it. Now I can multiply straight across and it'll be just like the 2 we just finished. 3 times 6 is 18. I want the x next and then the y squared. I'm just multiplying straight across and putting the letters in alphabetical order. In the bottom, I've got an x to the third and a y to the fifth. And now I'm able to reduce. The 18 doesn't reduce. The x's do, however. And I've got 1 on the top, 3 on the bottom, which means I'm going to have 2 left on the bottom. The y's also reduce. The 2 on the top will reduce with 2 on the bottom, which will leave me with a y to the third on the bottom. And one more. Stop the video if you'd like to try it on your own. All right. Since we're dividing 2 fractions, I'm going to write the first one down. And multiply it by the reciprocal of the second. All right, now we can multiply straight across and put your letters in alphabetical order. 6x, y squared. I'm just going straight across. I'm multiplying straight across on each one, okay? Let's see. When I multiply the denominator together, I'm going to get an 8. I've got x to the third. I've got 1y, and I've got 2 z's. A z to the 1 times a z to the 5th is a like-based problem, so we get z to the 6th. But now that'll reduce a little bit, won't it? 6 over 8 reduces by a factor of 2, which will leave behind a 3/4. An x in the top and 3 on the bottom reduce to an x squared in the denominator. The y squared and the y on the bottom reduce and leave 1 y in the numerator. And there's only 1 z term, and he's already got a positive exponent, so he's going to stay wherever he's at. All right, I'll see you in the next section.